Mr. Z here again, doing special cases. So we're still solving nonlinear polynomial inequalities, and we're still going to look for those critical points. But there are situations in which you'll see what happens here. Sometimes things don't work out quite as neatly as those first two examples. So looking at what we had there, last video we learned about solving polynomial inequalities. In this video I will talk about special cases for polynomial inequalities. So here are the three examples the textbook gave us. Sometimes you have imaginary zeros with regards to the quadratic, and therefore sometimes it's all real numbers, negative infinity and positive infinity. Sometimes we have no solutions. Sometimes we only have 1 point as a solution, and I'll cover that as well, which isn't listed here. But I'm going to go ahead and give you 4 examples. I'll try to go through them somewhat quickly, so you can always pause if you need to. And we'll go ahead and go over 4 examples, basically less than and greater than of each of these 2 quadratics. So we'll be able to go pretty quick, because we only have 2 real quadratics to factor. And these are easily factorable. If we have trouble, that might be an issue. And in fact, as I say that, this one is going to be a problem, because the factors of 3 that add up to 2, there isn't any. So now in this case, what I would say is I would want to use the quadratic formula, which means b squared minus 4ac. And again, if this wasn't in standard form, we'd put it in standard form. But in this case, we got lucky it was. And I ended up with 4 minus 4 times 1 times 3 is 3. 4 minus 12. And I get a negative value. And remember, when the discriminant is negative, that means there's no real solutions. So in this case, just for my own sake, I liked plugging in some values and seeing what's going on. And I need to plug in at least one value to figure out, is it always true or always false? If there's no critical points, that opens up the idea that it's either going to be entire number line, negative infinity to positive infinity, or it could be no real solutions. There could be nothing that solves this. And if I go ahead and plug in the most easy answer, the 0, I'm going to let x equal 0. I'm going to get 0 squared is 0, plus 2 times 0 is 0, plus 3 is greater than 0. That means 3 is greater than 0. That's true. Well, if that's true, and since we don't have any borders for our borderline, we're going to say it's the entire number line. And our solution set's going to be x equals negative infinity to positive infinity. And that's really all the work we have to do. I go ahead and I realize it's no real intervals we have. I plug in x equals 0. I get it's always true. So since it's always true, we're going to have all the numbers. Now, if you want to plug in a couple more, feel free to. To be honest, I did earlier, but I'm not going to waste your time doing that. Again, if you plug in numbers here, you're always going to get, even if you put in a negative value for x, the squaring of that value is going to make it bigger generally than the 2 times that value. Plus you have that plus 3 going on. It just ends up being that it's always going to be true. So that's the first special case. Second special case. Well, if I flip that and I did the same thing, b squared minus 4ac equaling 4 minus 4 times 3. Again, we have negative 8. There's no real solutions. There's no interval. Then I go ahead and I let x equal 0. In this case, if I put in 0, 0 squared is 0, plus 2 times 0 is 0, plus 3 is less than 0. 3 is less than 0. 0 is false. Well, if 0 is false and you don't have any place, that means all of them are going to be false, because there's no changing of continuity, or not, I should use that word, but there's no change. So there's no place to change. Since one's false, they're all false. So this would be x equals empty set or no solutions. There are no solutions to this. We couldn't plug in any value for x and make that inequality true. So that's the second special case. So we have no solutions. We just had all real numbers or all numbers, negative infinity to positive infinity. Now, another special case. Here, we actually can solve it. And in this case, I can factor that. If I factor that, I factor it into x plus 6 is less than 0. That means there's a critical point at negative 6. And if I hold true to what I always have said, well, first of all, it's not equal to, so it's a hollow point at negative 6, and that is false. If I plug in a negative 7, if I let x equal negative 7, I get 49 minus 84 plus 36 is less than 0. And in that case, that's 70, 85. 85 minus 84 is 1. 1's less than 0. 1's less than 0. That's false. This was an x equals 7. 1's less than 0. That's false. This is false. So it's not to the left of that critical point. What if I put in x equals 0? X equals 0 is 0 plus 36 is less than 0. Is 36 less than 0? No, that's false. So none of these are true, and in fact, the critical point was false too. So again, we're back to x equaling empty set, no solutions. And this is just a case where we have what's coming out of here, once again, is always going to be positive, except at negative 6. Negative 6 is 0, everything else is positive, therefore you can't make it less than 0. Well, with that same idea, I just thought, just to sort of come full circle, make sure everyone's understanding what's going on here, if we did the same thing but greater than 0, it may be obvious to some of you, but let's go ahead and do it. We have x plus 6 times x plus 6, this time greater than 0. That means x equals negative 6 is a critical point that is false. I'm going to go ahead again and circle that and say it's false. And in this case, if I go ahead and plug in values, if x equals negative 7 and x equals 0 will be my two critical points. At negative 7, I get, again, 49 minus 84 plus 36 is less than 0. Oh, greater than 0. Gosh. Slowing up here. Okay. Greater than 0. So I got that right. 36, negative 84. And again, that's going to be 85 minus 84 is 1. 1's greater than 0. That's true. So if this is true over here, we're going to go ahead and say that's true. To the left of negative 6. If I go ahead and plug in 0, I get 0 plus 36 is greater than 0. That means 36 greater than 0. Yes, 36 is greater than 0. This is true. We're also going to go ahead and shade to the right of that critical point. And a little more interesting is we're going to go ahead and have an interval x equals an interval from negative infinity to negative 6, not including negative 6, and then negative 6 to positive infinity. Again, not including the negative 6, and we never include the infinities. So that would be our solution for that case. And that's it. Those are special cases in which sometimes we have all but one point. Sometimes we have no solutions. Again, a no solution. And here all values are true. So that's our little quick review recap. Thank you very much. Next steps, go ahead and do the practice worksheet. There's 8 problems there for you to go ahead and investigate both just the regular nonlinear polynomial inequalities and then the special case nonlinear polynomial inequalities. Thank you very much and have a great day.